I want to talk you through how to figure out limiting reagents, how to calculate them, that sort of thing. Okay, so the limiting reagent problem is kind of one step on from normal grams to moles sorts of calculations. Anytime you're dealing with something like this, the first thing that you're going to be given is a chemical reaction. Whether it's balanced or not, that's what you'll be given. And your first order of business, no matter what other information you have here, whatever numbers you have here, you've got to make sure it's balanced first before you do anything else. If it's not balanced, your mole-to-mole ratios are going to be messed up, which means your answer is definitely going to be wrong, unless the equation is balanced already. So you always want to make sure and check that it is balanced, all right? Now you can see already this one's not 3 carbons, 1 carbon. So what I'm going to do is go ahead and balance this. I got my carbons balanced, I got my hydrogens balanced, I got 4, 6, that's 10, so that is going to balance everything. That's everything balanced. Okay, now in previous reactions, in previous questions, what you may have seen is, if I have 12.75 grams of propane, how many grams of CO2 will I get? Well, that's just a case of going from grams of propane to moles of propane to moles of CO2 to grams of CO2. The problem apparently becomes now then with, well, I've got 2 numbers. What am I supposed to do? Do I just pick one and use it? Or, well, no, you have to figure out which one is present in the least amount, or which one's going to give you the least product. And that is what we're going to do in this part 1. Which is the limiting reagent, all right? What I'm going to do is, I'm going to use essentially the same method that the book uses. I'm just going to go through it in hopefully what's more of a fluid rather than static way. So I'm going to start off with my grams of propane, and you're going to find this entire reaction, this entire question is going to be answered by essentially doing the same thing twice. I'm going to do the same thing 2 different times, once for propane and once for oxygen. So what I'm going to do is, I'm going to try to answer parts 1 and 2 together. I'm going to start off with my amount in grams of propane. Now down here I'm going to have my amount in grams of oxygen as well. We're going to get to that here in just a minute. So I got my grams of propane. My idea is I need to figure out a way to convert from grams of propane to grams of CO2. Now this is something that we've done before. You use the molar mass to go from grams of propane to moles of propane. Then the molar ratio from the balanced equation to go from moles of propane to moles of CO2, and then the molar mass of CO2 to get the grams of CO2. So I'm going to go through my conversion factors. First up is grams to moles of propane. I know whenever I go from grams to moles, I always have 1 mole of whatever it is I'm talking about. In this case, whatever I'm talking about is propane. And that weighs 44.11 grams. All right, so all I took was just add together 3 carbons, 8 hydrogens, and I got this molar mass. So in 1 mole of propane, it weighs 44 grams. But I don't want moles of propane. Ultimately, I want grams of CO2. So after I've done this first part, I'm going to figure out how to use my balanced equation to get 2 moles of CO2, because I have moles of propane. And I know that according to my balanced equation, I'm going to have 1 mole of propane. Because you have that 1 right there. And you know that's going to be on the bottom because here propane is on the top. And I want those to cancel out. 1 mole of propane is on the bottom. So therefore on the top must be the number of moles of CO2. And again, that just comes from the balanced equation. Hence the importance of having the equation balanced. All right. And then after you've got to moles of CO2, you can get to grams of CO2 without much of a problem. It's just a case of adding up the carbon and 2 oxygens, and knowing that in 1 mole of CO2, that weighs, I think it's 44.01 grams. Now, I'm just going to put CO2 here just to make sure we know what we're talking about. And then I'm going to make sure that everything that I want to cancel is cancelled. I got grams of propane gone, grams of propane gone. Moles of propane gone, moles of propane gone, moles of CO2 gone, moles of CO2 gone. Meaning my answer is going to be 38.25 grams of CO2. In other words, that's how much CO2 I would form from 12.75 grams of propane. Now, I can't answer which is the limiting reagent yet until I've gone through the exact same thing with my oxygen. So that's what I'm going to do. I'm going to take my grams of oxygen and go through exactly the same 3 steps here. So I know that 1 mole of oxygen weighs 32 grams because oxygen is 16 grams. All right, 16 grams per mole. And then when I get to moles of oxygen, I want to get to moles of CO2. I'm just going to make sure I use my coefficients from the balanced equation. I'm going to put my 3 moles of CO2 on the top, just as I did over here, except on the bottom now, rather than propane, I'm putting oxygen. And from the balanced equation, that was 5 moles of oxygen, so I'm going to put that right there. And then the very last step is, this is one of the nice things about this method, is the very last step for both is exactly the same, because I want to go from moles to grams of CO2. So I'm going to write out 1 mole of CO2 weighs 44.01 grams of CO2. Now, it's probably not much of a stretch to see that you can cancel things out exactly the same way you did before. Up here, I'm going to cancel out everything that I want to cancel, and what I get in this case is an answer of 15.61 grams of CO2. In other words, if I reacted 18.92 grams of oxygen, what I get out is this amount of CO2. If I reacted 12.75 grams of propane and enough oxygen to react with all of that, I'd get 38.25 grams of CO2. The one that's the limiting reagent is very simply the one that produces the less product. There's clearly less product here. It doesn't mean this is the limiting reagent, though. This is the limiting reagent. The limiting reagent is either going to be one of your 2 reagents mentioned in the question. This just gets you to figuring out which is the limiting reagent. So therefore, the limiting reagent here is oxygen because it produces the less product. And like I said before, the nice thing about this method is it allows you to answer part 2 at the same time as part 1. I could have calculated grams of H2O, the other product, if I wanted to figure out which was the limiting reagent, but I figured that since this question already asked me about grams of CO2, let's just use CO2 in part 1. And so the how many grams of CO2 is going to be formed is going to be the amount formed from the limiting reagent. Therefore, that's how we went through this. We figured out this is the limiting reagent, or rather the oxygen is the limiting reagent, and it produces this much CO2, so therefore 15.61 grams. Therefore, our answer to part 1, oxygen is the limiting reagent. Part 2, 15.61 grams is produced. And that, in essence, is how you do limiting reagent questions. It's as simple as that.